stuff. So this way you have to sit down, look at the question and then start running in your mind. This one will be solved by this one will be this. If I find this, I can use this. Clear? This one you take the picture. This is important. The resistance of a solution is equal to the constant multiplied by the cell constant. This is from CH 101. Well, I've given you the formulas, I think.
Yeah.
In the final paper, the formulas are given, right?
Yes.
This one too. So, you need to understand what it means. In a solution, when you pass the current, you see that the plus and the minus start migrating. When they basically move in the solution, they experience a lot of resistance. Because the chlorine might not allow the chlorine to move. Then sodium might meet chlorine in the middle and try to stick together. Right? Then you get water molecules all surrounding it, which does not allow it to move. That's how we get the resistance. Right? The more ions you have in the solution, the higher the resistance. So, how do you measure this resistance? You have to get some kind of electrode or some kind of device, probe. And that probe is basically given the cell constant. Because if you use the probe in order to determine the resistance, then that probe condition has to be known. Right? And the way the probe basically works is very simple. The way the probe works is very simple. You've got two platinum wires in the probe that is separated by a distant wire. Right? So when this probe goes into the solution, the ion basically moves through this distance here. Clear? So if I use the same probe to find the resistance of all the solution, then I have to know that my probe is having this constant. Then I can do that with other solution. Clear? Just like for example, we came in, we've got 20 posters that have come in for judging. Right? Should we give it to 20 different people to judge separately or one person to judge the 20? Why? Because a person who is going to do the judgment has to be constant. If I have to give it to another person to do it, then that person has to do all the 20, isn't it?
Yes.
So that we get the constant result from their constant. So likewise here. So if I have to measure the conductivity or the resistance of a solution, I have to keep my probe constant. So indeed, this is the distance the platinum electrodes are. That gives me your L. And the A is basically the area around which the ions can go in and touch. Understand? So the way we measure the cell constant, we can do it two ways. One, you do it directly, or the second one is indirectly. The direct method is when you are preparing your electrode, you would know the distance. So you calculate your L yourself. You know the diameter of the platinum wire that is surrounded in here, then you will know the A. So you get your A and L value directly. But if you buy an electrode which is from the manufacturer, then you can't open that up. And what the manufacturer will do, they will not give you the value of A and L. They will give you a solution of KCl together with the machine. And that is the indirect method. Eh? So in the indirect method, the solution of KCl that is given, the conductivity is known. They'll tell you this is the conductivity. So you dip your electro or the probe in the solution of KCl, you know your K, you find your conductance. So once you know your conductance, you see conductance is equal to 1 over R. So if I am able to find my conductance, I can find the resistance of the solution. Likewise, coming from here, indirect method, I will be able to know my cell constant provided I know my conductivity which is provided in the solution. Conductance is the reading I'll get on the meter. So if I know K, kappa and G, I can calculate my cell constant. I would love you to know all this. Because you know when you come after one more year to do the demo in 203 and students are lost in the electrochemistry section, I expect you to go to the student and explain like this, not stand in the corner there and then full time take the money, go home. This is why I keep on coming to the class and saying that no, you should understand. Because if there is a need for you to come in the lab, you need to come and start helping the student because you know your fact. And if you don't want to learn here, then you know over there, when you come in, then you should be asking yourself a big question mark. Am I doing the right thing for the students? Because when you have the opportunity to learn, you learn it. There, nobody will come and teach you again. Eh? You'll have to learn it yourself then. So might as well, while you are doing it, learn it here so that when the need comes for you to use it, you'll be able to do it. So understood this part. Direct method, indirect method. Conductivity, conductor, cell constant. Indirect method. Once you know this part, then you have to use the same probe to do the analysis for all other solutions. Right? Example here, conductance of a solution. So if you take some salt or whatever it is, you dissolve it in water, the conductance that you get on the machine is basically the conductance of water plus the conductance of your salt. I've given an example there, conductivity cell with 0.1 molar DM cube solution of potassium chloride at 25 degrees Celsius has a resistance of so and so. You are asked to calculate the cell constant if the conductivity of a 0.1 molar DM cube solution of potassium chloride is given. So can you see straight away the sentence tell you indirect method. That's what we are trying to say. From the sentences, you know, when you look at the long sentence, those things the question are finished, throw the end out. It's not like that. It's about grasping the main stuff. Eh? So up to here, what does it mean? You find the cell constant because I'm giving you KCl. Eh? The concentration is given and the conductivity is given. Then I have to go on to make it more difficult by asking you that if the conductivity of water is given, so what is the conductivity of that, right? Remember, water also have got conductivity because of the OH minus and H plus moving. And because of that plus and minus difference, you add anything which is polar, it will dissolve in water. So what you get here is a combined total. So if I give you this, you know the total, you can find this. But first we have to know the cell constant because the probes that you are using. I think this is one of your questions in the tutorial as well, where the conductivity of water and KCl is provided and you are asked to find the conductivity of H plus. Okay, strong and weak electrolyte. Again, this is from CH101. Strong electrolytes are any salt that completely dissociate in the solvent. Weak, they don't. We looked at the measurement of conductance, probe, direct method, right? Direct method and indirect method. Variation of conductivity with concentration. So the expected line is the depth one. For a strong electrolyte, conductivity should increase with concentration. Why? Because you are adding more ions to it. So if we have more salt, it gets it dissociate, get into its ionic form. However, you see the observed one like this. Expected is here, observed is here. Why? Because if the concentration of the salt increases, not all the salt then can dissociate. Because if one dissociates, the other one will hold it. Don't fix it. Clear? So here what you see is that the solution is now becoming saturated. So that is why instead of seeing an increase, you see that it starts to diverge. That means that the equilibrium is being reached. That it cannot dissociate any longer. So that's what I have written there. Concentration increases, amount of ion increases, conductivity increases. But due to the increase in more ions present, resulting in greater attraction between the plus and minus ions, and because there is confined of space for the salt to dissociate, it doesn't. However, with ethanoic acid, please be mindful of the Y gratings here. We're starting from 0 going up to 150. That's why we get a graph like this. But for this one, you are starting from 0 and hardly ever reach 0.2 or 1. We are all below 0.5 here. Which means the graph is almost level here when compared to the previous one. Almost 0. It indicates that ethanoic acid is a weak electrolyte, does not dissociate. So concentration increases, the amount of ethanoic acid molecules increases, but does not fully ionize. And that's why conductivity gradually tries to increase with concentration, because the more you add, very likely chance that a few will ionize. Now, while we are on this, HCl, write it. H2SO4 and HNO3. Which one is the most strong acid of the three?
HCl.
HCl, H2SO4 or HNO3?
HCl.
HCl?
Yes.
No?
Sulfuric.
How do you decide the acidity?
pH level. And dissociate
pH means
hydrogen ions.
H plus concentration. Which one will have a high H plus concentration?
Sulfuric.
Huh?
H2SO4.
H2SO4?
Yes.
HNO3. I tell you why. You write the dissociation of HCl. HCl will break up to give you H plus N.
Cl minus.
Can the Cl minus hold the H and go back? Yes. The H plus can hold the Cl and go back and become HCl. Look at the next one. H2SO4. It will break up to give you 2H plus and
SO4 2 minus.
SO4 2 minus. Is SO4 2 minus happy? No. It needs a H. So it might go and bring one H first. Then it will become SO4 H minus. Yes?
Yes.
So is the H free? Look at HNO3. So HNO3, the H goes. NO3 minus is left. Can NO3 minus be in resonance structure? That minus can go to this O, this minus can go to that atom, and then keep on changing. Do they need the H plus?
No.
Huh? Does the NO3 minus need the H plus after in resonance stabilization? No. So where is the H plus concentration high? HCl, H2SO4, HNO3.
HNO3.
If you don't know this at 200 level, then something big question mark on you. And when I ask you questions like this, then you people write, oh, your course is very hard. You know, your course is very difficult. You should run special classes to answer all this. This is physical chemistry. Physical chemistry means we try to explain why certain things behave like this. And you did all these things from your 101 and 102, isn't it? Resonance stabilization, you did it in 101 and 102. But many of you were not in the class, that's the problem. So when you come to higher level, when I start asking you to explain things in terms of its application, H plus 1, I will come to your question, pH. Because we'll calculate the pH, right? So here I'm just showing you the data for weak and strong electrolyte. Molar conductivity. Molar conductivity basically decreases with increasing concentration. Why? Because of the formula. The formula for molar conductivity is given as this: conductivity divided by concentration. So can you see if concentration increases, conductivity increases. Because in order for me to put C that side, it's a direct relationship. Conductivity increases, concentration increases, conductivity increases. But in this case, can you see molar conductivity is inversely proportional to concentration. So the higher the concentration, the lower the molar conductivity becomes. Trick here is conductivity is normally given in centimeters squared per mole and concentration is given in moles per dm cubed. So you need to bring it to the same term, which is centimeter cubed. And I've given this definition here because the last time I asked some engineers and they gave me the wrong answer. Then I said, okay, my chemistry student, when they make mistakes, it's fine. 1 meter cubed is equal to how many centimeter cubed?
1000.
1000?
Yes.
Wait,
No.
1,000.
1 million. 1 meter cube means 1 meter multiplied by 1 meter multiplied by 1 meter, which I have to convert to 100 centimeters multiplied by 100 centimeters multiplied by 100 centimeters. Answer becomes 1 million. Again, if you make mistake here, where is the problem? Chemistry?
No. Math.
Well, I don't blame you much because this course here is more physics and engineering based. You will see that if you happen to go overseas and look up the curriculum for chemical engineering courses, you will see you will be basically learning all this. And we can't offer chemical engineering here, definitely not. How many will pass? She asked me why, how many will pass? Because we'll have to go back and start teaching you almost an engineering concept from high school in chemistry. To understand those basic steps. 1 meter, 1 meter, 1 meter means million. Clear? It's nothing hard there. Can you see it's written cube? Cubed means this by this by this. Length and width and height. So 1 decimeter cube is how many centimeter cube? So it's going to be 1 decimeter is how many centimeters? 10.
10.
So 10 times 10 times 10. 10,000. Right? If you make this mistake in the third year, then do you think I should have mercy on you?
No.
I shouldn't have. Because I've explained it, you got it introduced one, it's your job to put it here. I can't come and open this part all the time and put it in, zip it up, and you open the zip and it runs away. When you get introduced, write it somewhere. Remember, it's a human mind, you might forget. That is why when you come to lectures, you have notebooks. So this is what people were saying before. You see, you forget. You hear, you forget. You write, you remember. That means you have done it. And nowadays people are more forgetting because they'll never go back to see. And if they see, don't see, or they remember. That is why when you come here, it's best to write something in shortcut so that you can go back and recall. This is what it means. Okay. This is 203 because I removed this from 101. The dissociation behavior of ions in weak electrolyte during the Arrhenius theory of electrolytic dissociation. Just look at what we have done in the formula. Nothing difficult. AB actually dissociated to A plus and B minus. How do you write the equilibrium constant? Product over? Have we written that here?
Yes.
So minus plus comes here, AB comes here. Right? Now what we are saying, that if 8 and B is equal to the concentration multiplied by the dissociation factor, alpha. Right? So if A plus and B minus have the same concentration, isn't it? But the dissociation factor is same as well, 1:1. So AB will be whatever they have not dissociated. So you got 1 minus, right? So it would be like this. 1 minus C alpha. Because we have a concentration here which is supposed to dissociate. So this was the factor by which it dissociated to come here. The remaining one will be minus from there. So what do you do? Once you know this, you just go back and put it here and do this and we get this. Right? I'll come back later to show how we can calculate the alpha using another technique, then come into here to find your K value, which is the equilibrium constant. The Debye-Huckel theory to explain what is the atmosphere around the ions when you apply the potential. In a normal solution, when we don't apply the potential, the plus and the minus are all moving freely in the solution. Right? This is almost like what we call isotropic. Isotropic means no separation. As soon as you apply the potential, then the minus will go to the plus and the plus will come to the minus. That's when we have an asymmetric effect and the electrophoretic effect. How? In the asymmetric effect, the plus and the minus are all surrounded by the obliquely charged ions. So the moment you apply the potential, those obliquely charged ions will not allow it to move. So that's why you will see sometimes in your measurement, you'll see a slow start. And the electrophoretic effect, when they start moving, because water is also highly charged, it will tend to hold back. And then the potential or the speed at which the ions move to the opposite electrode, they slow down.
Yeah.
Controlled law of independent migration of ion. I did explain this in CH 101 very clearly. How many of you understand or recall? Remember I said in the lecture, you are you.
You.
Which means whether you come from your siblings or you are attached to your parents, you are you. Depending on which different environment you are in, you still you. So, if I have a Cl coming from the Na, Cl coming from the Mg, Cl coming from calcium, no matter which salt it is coming from, Cl is Cl. So then what it means? Independent migration. That means it will work on its own, regardless of the salt it is coming from. So if I know the limiting molar conductivity of chlorine, right, Cl, whether it's coming from sodium, whether it's coming from magnesium, I can still use that data to calculate something. Understand?
Yeah.
So that's what law of independent migration means. If I come into the class and go like this, at infinite dilution, each ion contributes to the total molar conductivity, and the definite share will depend only on its nature and not with it is associated with. That's called Roche law. Next slide, we'll move on. Will you understand? The way I told you, did you understand? It took time for me to understand. Clear? And that is what people will be expecting from you when you go into this system. And if you don't learn it now, then remember one thing, when you come into the class, the mind only can concentrate for 15 minutes. That's why I tell you the theory and go on the story. So that your mind gets attracted to that story and then it's more related to your theory. Then I come back. Because the human mind only can concentrate for 15 minutes. But you need to discipline yourself. Put the phone on the side and then listen to me. Not start, heart. You know? If you do that, you'll never learn. I'm telling you. Because what happens, your mind is distracted, it's already not concentrating. And then when you tend to miss the main point, the other part becomes harder. That's like when you are watching a movie and you miss the main point, then after that you try to figure out what's going on there. Yes or no? So, understood this concept?
Yes.
I'll give you an example here. Can you see H has got this value. No matter where that H is coming from, it will still have that value. Lithium has got this value. No matter where it is coming from, lithium will have that value. Whether I associate it with chlorine, bromine or whatever, it still will have that value. So if you see here, BaCl2, then what I have to do is break it up. It will go into Ba2 plus 2Cl minus. So I can go to this table and bring barium here and then chlorine here, right? Why am I able to do that? Because chlorine is chlorine, no matter where it's coming from. Barium will be barium, no matter where it's coming from. And then the final answer that you get will be for barium chloride. Clear? We normally use this data to calculate the limiting molar conductivities of weak electrolytes. Because weak electrolytes don't actually dissociate. So you wouldn't be able to know what is the limiting molar conductivity, the real value for a weak electrolyte. So what we do, we think that if this one will dissociate, then we try to see the limiting molar conductivity from the table and calculate and then put it there. Example here. We are to find the limiting molar conductivity of this weak acid. So can you see, if I break this up, it will give me CH3COOH. Right? So where else can I get the H from? From a strong electrolyte, HCl.
Yes.
Because if I take HCl, it's a strong electrolyte, it will dissociate. I can get the H from there. Where can I get this part? I get it from this salt. Because if this one dissociates, it will give me this plus Na plus. So I will get this. Right? But I don't want, so in this case I have HCl plus this. But I don't want the Na, I don't want the Cl, I have to minus NaCl. So that's how it is done here. This plus this minus this. Because if I take this, I am getting this part plus the sodium. With this, I am getting the H and the Cl. If I subtract NaCl, I get rid of Na and I get rid of Cl. That's algebra kind of thing. A plus B minus this, and then you solve it. Once I gave the question like this, with COOH here and find this. You know, all the students did the problem. Except one student who said, question wrong. We should use a strong electrolyte to find the weak one. And CH3COH is a weak electrolyte, whereas this is a strong electrolyte. So you didn't do the calculation, it should get full marks. You know, here we give you question where you have to do it all the time, you expect to do the question. We should now start giving you questions which are wrong. We should give you wrong questions. And then you should be able to figure out whether the question can be done or not. If you can figure that out, that means you are smart. You know the topic. So the point here is, if you are coming to learn, what are you coming to learn? Pass? Pass means what? Learn? No way. Learning means you should be able to tell from right and wrong. So the way we are actually giving you assessment, I think is not right. We should give you a mixture of all good and wrong problems. You should be able to identify these are all the good problems, so which we will attempt, these are all the wrong problems, we will not attempt. First part done. Then you go on to do the correction, the good problem or the correct problem, then do the problem. Just like nowadays you go headache, they must give you Panadol. Sometimes it's just water. You are dehydrated. So the answer there should be take some iron and drink water, and it should stabilize. But they have to give you some painkillers, Panadol. Yes? Because it has to be. Just like you are thinking that I come for the exam, it has to be solving problem. Okay, when I see you tomorrow, on Friday, Friday is the holiday, I'll still see you because some of you are coming to volunteer.
Yes.
You name your name there?
Where?
Okay, before you go, I just explain this word here, hydrodynamic radius. The new term. When you take a salt and you dissolve it in water, the plus and the minus ions get attached to water. So when the ion moves, it also takes the water with it. Right? So the radius of that ion is what? Just the ion or including the water? Hydrodynamic radius. See that? It is attached to the water becomes part of the molecule. So instead of looking at the ions only, you look at the total radius. That means from this to this. That's what it means, hydrodynamic radius. Right, I see you next week Monday. But during the week I will see you on Tuesday lab. This week is the lab, right?
Yes.
And the other thing, before you go, this week Friday is an open day. Okay, I'll tell you next week Monday.
Hey, how are you?
Where's you? You're gonna say.
Now I'm going for the presentation.